Okay, so today we are going to discuss the 9th chapter of the syllabus, that is estimation. It's very important, and the examiner would basically be asking questions from this chapter in paper 1. It's chapter number 9, that is estimation. Okay, now in estimation, basically we have two parts. We will be talking about significant figures and we will be talking about rounding off. Okay, and then you will understand at the end the idea would be that we would be giving estimated answer, approximated answer. The wordings of the examiner would be something of this type: approximate, give the approximate answer, estimate the value of. Okay, so this is going to be the idea. Okay, 1 second only, I need to admit Urva. All right, okay. So she is here. Okay. So this is basically the idea about the chapter that we would be discussing today. All right. Now let's talk about the first part of this chapter, that is significant figures. Okay. This is what we need to talk about for now. Significant figures. Okay. All right. So let's talk about significant figures. So I will be writing down a few numbers here and then you would understand the idea. Let's talk about example number 1. Example number 1 has 7.2. Now 7.2 is the number and we need to discuss the number of significant figures over here. Okay, so it's easy. The number of significant figures is basically the number of non-zero digits in a number, but it depends. Okay, when it comes to decimal we have some complications, but for now just know the number of significant figures is basically the number of non-zero digits in that number. Okay, so if I talk about 7.2, what would be the case? 7.2 has two non-zero digits in it. So I can say that it has two significant figures. Okay. This was the first example. Kabir has just joined. Kabir, we are discussing estimation. The first part of estimation is significant figures. And in significant figures, I've just told the definition that we will be focusing on the non-zero digits. Just count the non-zero digits and that is going to be the number of significant figures. Okay, we'll come to some exceptions later on. For now, let's keep it simple. Let's talk about example number 2. It has 18. So 18 again has two significant figures. All right, let's talk about the third example. It is 3.65. Now 3.65 has three significant figures. Okay. Then if I talk about another one, let's say 16.2. So how many significant figures do we have in 16.2? Yes. Please tell me quickly.
3.
Okay. And what about the other students?
3 as well.
Very good. Well done. Excellent, both of you. We have three significant figures. Okay. And then obviously we can talk about a lot of examples. If I say if I have a number of this type 11935, now we have five significant figures. If I say the number is 11.291, again we have 5. So you can see that the decimal is not making any difference. The idea is same, that we are just counting down the non-zero digits. Okay. All right. Now, this is when we do not have a zero. Let's talk about the numbers having zero, that what exactly is the case over there. Okay. So this is the first part of significant figures. Let's talk about the second part of significant figures. Okay. Now let's say we will talk about numbers having a zero in them. So imagine you have 580 as the first example. What do you think? All right, just 1 second only. All right, so yes. So what would be the number of significant figures in this one, 580? What do you think? Just a random guess, because for now I told you significant figures is basically the number of non-zero numbers. Okay. So what do you think? Just a random guess. How many significant figures would we be having in 580?
3.
Okay. What about Urva, Omaiza, and Kabir? Yes. What do you think? If I told you that the definition of significant figure says the number of significant figures in any number is basically the number of non-zero digits. This is the most simple example. We certainly have some exceptions, but for this case, this would work. Okay. If you look at 580, and if we count the non-zero entries, the non-zero digits, what do we see? We have 1, we have 2. This means that we have 2 significant figures. Now, some people say that you can also write it as 3 significant figures. That's also correct. But according to the syllabus, we need to understand it this way, that if a 0 is coming at the end, and if we do not have a non-zero number after a 0, then it would not be considered as a significant figure. It basically means if I had 5802, now if I count the number of significant figures, I would count this one, 1, then this one, then this one, and then this one. So we have 4 significant figures now, because after this 0, we have a non-zero number. Okay. So this is how the definition is. In general, if I talk about the most basic example, we basically just count the non-zero digits and we say we have those many significant figures. But if we have a 0, and if after that 0 we have a non-zero number, then that 0 is also considered to be a significant number. Okay. So you can write it as if you have 4 significant figures. All right, let's talk about another example. This would get clear with examples, just don't worry. What if I say we have 807000? Yes, students, how many significant figures? Please answer me quickly. 1.
3.
Excellent. Very well done. 1, 2, and 3. three significant figures. Now, why didn't I count these three zeros? Because we do not count zero as a significant figure. But why did I count this zero? Because if we have a non-zero number after zero, like this one, then you can certainly consider the zero as a significant figure as well. Okay, Umaiza, Urva, and Kabir, is it making sense?
Yes, ma'am.
Okay, Kabir and Umaiza?
Yes.
Okay. All right, perfect. And it would obviously make more sense when we will talk about the question. So don't worry about it, okay? Acha. All right. Let me just talk about few more examples. Now let's say I have 1508.23. So how many significant figures? We have 4 and we have 2. So we have 6 significant figures. Okay, so now we are clear about the understanding of zero. If zero is coming at the end, that would not be considered as a significant figure. But if that zero is coming before a non-zero number, or if let's say if you have a non-zero number after that zero, it would certainly be considered as a significant figure. Okay. All right. One last thing that we need to understand, that's a little different. Okay. Now here we will be talking about decimal numbers and zeros. Okay. Now let's consider an example. Let's say you have 0.00003400. Yes, just a guess. What do you think? How many significant figures do we have here?
7.
Okay, so I got 4 as one student said 4. Who said 4?
I said 7.
Okay, so Taha said 7 and who said 4? Nobody said
No
4.
one.
No one. Okay, all right. Okay. So one student said 7 and that is it. That was the only answer. Okay, now I don't really understand from where exactly you got this 7. So can you please tell me you counted these numbers as significant figures? Yes, Taha, please confirm how exactly you said 7.
You count from 0 point,
Okay,
0
okay.
point and to 3.
All right, so you counted 0 point as well. Okay, all right. So your understanding is completely fine. This is what we have been discussing, that if we have a number, we will just count all the non-zero digits, and if we have a zero coming at the end, we would ignore that. But if we have a zero in between such that we have a non-zero number after that zero, that would also be considered as a significant figure. That is fine, but this is third category. This is a bit different. Okay, how is it different? It is different because in the previous numbers, if I go back to the previous numbers, if I talk about this zero, so we had a non-zero number before it and a non-zero number after it. If I talk about this zero, I had a non-zero number before it and a non-zero number after it. If I talk about this zero, a non-zero number before it and a non-zero number after it. So that is why the zero was considered as a significant figure. Okay, that is clear. That is good. But if I talk about decimal numbers or numbers of this type, for example, if I talk about another example, let's say 0.01204 and such examples. So these are different. Here the working is starting after decimal. The number is starting after decimal. So we have a rule here. Okay, I will be writing that rule just so we are clear with the idea. According to the rule, The rule says that these are basically the leading zeros and these are the trailing zeros. All right. So for such numbers, we have two type of zeros. Those zeros which are coming in the beginning, we call them the leading zeros, and then those zeros which are coming at the end. For these type of numbers, the rule is a bit different. Okay, so we do not consider them as significant figures. No, these are not considered as significant figures. This is the first significant figure. This is the second significant figure, and zeros after non-zero digits in a decimal are significant. So this means that this would be the third one and this would be the fourth one. Okay. So let's keep this on hold and let's talk about whatever we have discussed in the beginning. The first case was simple. We just had non-zero numbers. We just counted the numbers and we said we have those many significant figures. This was easy. Then we added zero in our life. When we added zero, the first example was 580. The zero was coming at the end. So I said the number of significant figures in 580 would only be 2 because we do not have a non-zero number after that zero. Okay, so this became a rule that if you have a non-zero number before and after that number, that zero would basically be considered as a significant figure. For example, this zero was considered as a significant figure because we had a non-zero number before it and a non-zero number after it. This zero was considered as a significant figure because we had a non-zero number before it and a non-zero number after it. This zero because we have a non-zero number before and a non-zero number after. But situation changed by the third type of the questions. If we talk about the third and the last type, here we only have these type of numbers like 0.00 something. The zeros which are coming before the number are basically the leading zeros and they are not significant. But the trailing zeros, the zeros which would come after the decimal or after the non-zero number would basically be considered as significant figures. Okay, let's talk about some examples and then this thing would get clear. Example number 2, 0.01204. Okay, now this is a leading zero, so this is not a significant figure. This is the first significant figure, this is the second one, this is the third one. Why is it a significant figure? Because we have a non-zero number before and after it, and then this is the fourth significant figure. So we have 4 significant figures here, and here we also had 4 significant figures. If I talk about the third example, so this time around we have 103.45. Okay, now this is basically a combination of what we have discussed. Again, we have a zero here. Now this zero is basically coming between two non-zero numbers, so this would be considered as a significant figure. So in total, we have 5 significant figures in this number. But what if I add a zero here? How many significant figures would we be having here? Can anyone tell me? This zero is basically considered to be as
5, I think.
this zero is considered as a trailing zero. We have a decimal. After the decimal, we have a non-zero number, and after that non-zero number, we have zero. So this is basically a trailing zero. So you can think about it as if you have 6 significant figures. Okay. The rule for decimal is a bit different. If you have a decimal number, just know this. If you have a decimal number, this is a decimal number, this is a decimal number, this is a decimal number. If zero is coming at the end, it would be considered as a significant figure. Just know that. That is it. Okay. For decimal numbers, whenever 0 is coming at the end, or if zeros are coming at the end, they would be considered as significant figures for decimal numbers. Just know that. For example, one last example could be if you have 0.123456. Here we have six non-zero numbers, and we have 1 0, and this is basically a decimal number. So in total we have 7 significant figures. Yes. Any confusions? Let me just quickly go through all of this and then we'll talk about it. I hope the old
No
idea.
confusion.
All right, okay, great. I hope that the like the first part was very easy. Now in the second one, whenever the zeros are coming at the end without decimal, they are not considered as significant figure. That's fine. Whenever your zero is coming between two non-zero numbers, that is considered to be a significant figure. And whenever we have a decimal number, this was 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 a decimal number. Whenever we had zeros at the end, like these zeros, like this zero, like this zero, these zeros would also be considered as a significant figure. Okay. So yes, Urva, Omaiza, Kabir, please tell me if you have any difficulties with this.
No, ma'am.
No, ma'am.
All right. Okay, great. So this is basically used for rounding of numbers. Okay. Here is basically how estimation is used. Okay. Now let me just take out another page. Now let's discuss rounding. Okay. Let's talk about rounding. Now in rounding, the questions would be something of this type. Round numbers to, for example, one significant figure. Let's say the number is 7.8. Let's say the number is 18. Let's say the number is 3.65. Okay. We have these three examples and they're enough. So if the examiner wants you to convert the number to one significant figure, this means that we only need this number, we only need a number here, and we only need a number here. If you need this number only, just look at the other number, the second number. Okay. If the second number is greater than 5, this would mean that I can add 1 to the previous number and it would become 8. 7.8 was the number. We want to round it off to one significant figure. For rounding it off to one significant figure, we need to look at the other digit, and the other digit is basically 8. If the other digit is 5 or greater than 5, you can just add 1 to the previous one and write it down. For example, let's talk about the second example. This was the first one. This is the second one. I need a number here. Now the number could be 1 or the number could be 2. It would be 2 if the number after this one is 5 or greater than 5. Now I can see that I have 8 here. 8 is certainly greater than 5, so I can write it as 20. Third example, we have 3.65. I need to fix this one. For this, I will just check out the other one. That's 6. 6 is greater than 5, so I can write it as 4. So this is how we round off numbers to one significant figure. Let's talk about some more examples. (16.2), 9.1, and 1180. Yes, all of you. Please pay attention and just tell me, how do I round it off? Yes. Again, the question is about rounding it to one significant figure. So one significant figure would mean 16.2 would become what? Okay.
Ma'am, I think it
It
would
will
become
remain
16.
16.
Very well done. It would remain 16 because when you will try rounding it off, now we have basically a discussion here, okay? If the question says simply round off the numbers and estimate your answer, there you can just, round off the numbers according to your choice and that way. But if the examiner is clearly mentioning, if they want you to give the answer up to one significant figure, then if you say that 16 would be the rounded off number, 16 has two significant figures. So 16 is not the right thing. Yes, if you round this off, this would give you 16. I agree. But if you have been asked to round it off to one significant figure, then what about that? For that, you need to know one significant figure means only the first digit. So we only need a number here. If we need a number here, we will just check the other number. The other number is 6. It is greater than 5. So I can round it off to 20. 16.2 can be written as 20 if the question is about rounding off the number to one significant figure. Okay. Yes, because
Understood.
yes, because either the 16 could be 10 or it could be 20, but it's more close to 20. That is why it is 20. Okay, Umaiza, now listen to me once again. Listen to me once again, okay? Just listen to me. 16.2 was a number, and the question clearly says round numbers to one significant figure. Some of you said when we will round off 16.2 to one significant figure, it would be 16. But we have just discussed significant figures and we know that 16 has two significant figures. So if the question says one significant figure, I need to do something with this number. It would either remain 1 or it would become 2. It would remain 1 if this number was less than 5. But since this number is greater than 5, so I need to add 1 to the previous one and it became 20. Similarly, let's talk about more examples and it would get clear. I have 9.1 here. Again, the question says one significant figure. Because if I talk about 16, I cannot say it would be 2. When I will round off 16, it can either be 10 or it could be 20, and 20 has one significant figure only. You know that, right? We have a 0 at the end, and this 0 is not significant because it's coming at the end. So this is basically a number with one significant figure. I can't say that 16 can be rounded off to 2. That's mathematically incorrect. If I make the number line, this is 0. Then let's say this is 16. I have 10 here and I have 20 here. So either it would be 10 or it would be 20. So 16 is more close to 20. That is why I've rounded it off to 20. Okay. If I talk about 9.1, yes, very good. If I talk about 9.1, again, it says one significant figure. So only focus on this number. Either this 9 would stay 9 or it would become 10, right? 9 would be rounded off to 10. So for this case, I will just look at the other digit. That's 4. That's 1. 1 is less than 5. So I can write it as 9 directly. Now 9.1 is rounded off to 9. If I explain that on number line, let me just quickly do that. This is 0. Let's say this is 9 and this is 10 and this is 9.1. One significant figure means either it would be 9 or it would be 10. Okay, so it's more close to 9. That is why it is 9. What about the sixth one? Can anyone tell me what would be the answer? Again, the question is about rounding off the number to one significant figure. So forget about everything. Just focus on this number. It's 1. So it would either remain 1 or it would become 2. We need to look at the second number. The second number is less than 5. Since the second number is less than 5, so my number would be 1000. It would be 1000. Okay. Again, I can represent that on my number line. So imagine this is 1000 and this is 2000 and here is 1180. Now 1180 is closer to 1000. That is why I've rounded it off to 1000. You can use the number line method or you can just use this basic knowledge. If it says one significant figure, it means the first digit. Just look at the second digit. If the second digit is less than 5, the number would stay as it is. If it is greater than 5, you would add 1 to the previous one. Let's talk about a lot of more examples and then this concept would get clear. Okay. All right. So let's consider a few examples here. Okay. Now let's say the question says, round off to two significant figures. Now it says you need to round off to two significant figures. Okay, Umaiza, I'll explain this again over here and then it would be clear. Okay. Now, just listen to me carefully, all of you. The first one is 3.87. Okay, all right. It's very easy. Trust me, it's easy. It says two significant figures. So I will be talking about this one. Okay. Now this is what I have. I have 3.7 and I need to round it off such that I'm left with two significant figures. All right. Okay. We would be having some exceptions here, but most of the times the idea would be same. Very well done, Umaiza. Now it was two significant figures. So I was focusing on this number. This number was 8. The number after 8 is 7. 7 is greater than 5. So I will add 1 to the previous number and it would become 3.9. Okay. Let's talk about another example. Now imagine that you have 15.9. Two significant figures. Focus on this one. So the next one is 9. 9 is greater than 5. So I will add 1 to the previous one and it would become 16. Third example is for you guys. Please try doing it. I'm pretty sure all of you can do it. 18.7. Yes, quickly round it off. Very well done, Umaiza. Excellent.
19.
Very good. Well done. Okay. 19. Why? Because it's 8. The number after 8 is 7. It's greater than 5. So we will add 1 to the previous number. Okay. Let's talk about a different example or an exception here. Let's say you have 3.97. Yes. Now tell me. 3.97 is your number and you need to round it off to two significant figures. What do you think about it? Very well done, Umaiza.
I think 4.
Very good. Well done. Okay. Now what's happening? Again, this is the number. The next number is 7. The next number is greater than 5. So it means that this 0.9 would be converted. But when I will convert this 0.9, I don't have a number. Okay. So this entire thing would become 4. So you can write it as 4.0. So at times we can have such exceptions where we would be having a 0 at the end and still this obviously is a significant figure because it's coming after the decimal. But for example, let's talk about another example. Fifth one, let's say you have 1980. Yes. Convert this to two significant figures and what would you get?
2000.
Very good. Excellent. So we will be focusing on this one. The next one is greater than 5. So I need to round off 9. And when I will round off 9, this entire thing would become 2000. Very well done. Yes, Kabir and Urva, are you guys able to understand this? Yes, Sumaisa, definitely. You can just do it directly as well.
Yes, ma'am, understood.
Okay,
Yes, ma'am.
perfect. Very good. Okay, and yes, Sumaisa, for these questions, the question would basically, I'll just write down one quick past paper question, and then let's talk about it. Then you will understand. The question would basically be of this type. And this would come in paper 1 where calculator is not allowed. Okay. So it would be estimate 15.9 multiplied by 3.87 divided by 18.7. This would be the question, and the examiner wants you to estimate without calculator, and he's not that cruel. He would understand that you need to round it off first and then you will answer. So for such questions, the policy is just round off every number to one significant figure and then answer it. Now some students just convert it to, it depends upon them. Okay, I'll talk about two solutions for this one and both are correct. One would take less time, the other one would take more time, but it's completely your choice. Okay, the question says estimate. When it says estimate, the examiner would not expect that you will give an exact answer. The examiner would know that the answer is an estimated answer, and this estimated answer would come when we will round off all these numbers. So 15.9 can be rounded off to one significant figure and it would become 20. Very good. Excellent. And then 3.87 would be rounded off to one significant figure and it would become 4. 18.7 would be rounded off to one significant figure and it would become 20. So I can write it as 20 multiplied by 4 divided by 20, and you can just say that the answer is approximately 4. Okay. Very good, Umaisa. Now, if you try, plugging in these values in the calculator, let's just see what do we get. The answer would be very different. The answer would be very different, but that does not matter. We were just asked to estimate. The answer is 3.29 something on the calculator, but the calculator would not be allowed in this exam, so we will be estimating. This is one method. This is also correct. If some student wants to be, extra good, and if you want to get a more precise answer or a more accurate answer, just round off the numbers according to your convenience. Okay. So 15.9 can also be rounded off to two significant figures. So one might say that 15.9 is approximately 16. Then 3.87 is approximately 4. And then 18.7 is approximately 19. But now when you will do it, it would take good enough time, but the answer would be more precise. Okay. So when we will be discussing past papers in detail, I'll show you the marking schemes. For such questions, the examiner would give a variety of answers, a range of answers, and all the answers lying in that range would be correct. It could be that Umaisa is getting this answer and Kabir is getting this one, Taha is getting this one, and Moiz is getting this one. So both would be correct. But obviously it depends. We do not have a hard and fast rule here. Estimate means just estimate according to your convenience and find the answer. Okay. So this is how it is. So now tell me if you were not able to understand anything, any difficulties, any confusions here.
I understand.
All right. Okay. And Umaisa, Urva, and Kabir.
Yes, ma'am, understood.
Okay. All right.
Yes, ma'am,
So,
understand.
okay, great. Let me just stop